SwayamPrabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Good morning, welcome friends. This is a new course which is developed by Department of Maritime Engineering at IIT Gandhinagar and hosted under the auspices of SwayamPrabha at IIT Gandhinagar. Friends, this course is titled as Marine Renewable Energy Systems, where we will discuss about the complete analysis, design and development of various systems useful for marine renewable energy. The course will be mainly coordinated by me, who is currently heading the Department of Maritime Engineering at IIT Gandhinagar. A few lectures will also be shared by Dr. Basanagoda Patil, who has done extensive work on design and development of bio-inspired wave energy converters. Friends, this is a very interesting and important course in the current scenario of renewable energy where India is heading towards blue and green economy. Now we all understand that there is a huge demand of fossil fuels, hydrocarbon fuels being used in various modes of transport. Under the given scenario of confusions being arised in the global systems of supply chain in hydrocarbon and fuel systems, every country is now started harnessing on and dependence increase in its versatility towards design and development of green energy. So, India heading towards blue economy is also planning very rigorously and has already implemented various schemes on renewable energy. For example, solar power and offshore wind power has been in the peak rise in installations and harnessing of these energies along Indian coast. However, when you come to wave energies harvest, there has been a big myth about the analysis, design and development of these systems, and generally people think they are centric to the development in European and American countries. It is not so. It is very important to understand the basics of this, so that along given a very long peninsular coast along the country like India, we can harness wave energy much comfortable and more advanced than any other developed countries in the world. So, this course will be a good eye opener for people to learn and understand thoroughly the basics on marine renewable energy systems. It is not talking about the concepts and mathematics, it will deal with various aspects of design development, geometric forms, experimental studies on scaled models and detailed numerical analysis using various software like ANSYS Aqua, right from the scratch up to the end of harnessing and designing the wave energy converter systems, including the mechanical designs of power takeoff systems, etc. So, friends, let us discuss about few introduction on this course. Welcome to this lecture 1, which will talk about introduction of this specific course on marine renewable energy systems. Let us have a look at the course content of this particular course. Ma'am, I think this has got hibernated. Let us look at the course focus, what we will discuss in this course. The course will provide a comprehensive understanding of marine renewable energy systems. Of course, the primary focus of this course will be on wave energy conversion systems, but we will also discuss something about offshore wind farms design and development. In this course, fundamentals with respect to wave mechanics, wave energy resource assessment, different types of wave energy converters will be discussed and presented in detail for the benefit of the learners. A complete theoretical background which is required to understand the wave structure interaction, the hydrodynamics and energy extraction mechanisms will be presented in a classroom style, friends. It will be very interesting to follow these lectures for your own benefit and also for advanced research in this domain. Design principles of various forms of wave energy converter systems will be discussed in detail, which includes mechanical, wave energy converter, floating type, oscillating type and multi-body converters, which are all the specific objectives of this course. The unique aspect of this course is integration of numerical modeling with the experimental investigations. We will also show you certain experimental setup and certain videos captured during experimental conduct of various wave energy system models, which will be very helpful for you to have a virtual learning exercise of conducting these kind of experiments on scaled models of these devices. Hydrodynamic analysis using tools such as ANSYS Aqua to obtain response amplitude operators and also to conduct time domain simulations will be all discussed in detail, and this course will also help you to learn ANSYS Aqua step by step using screenshots which are applicable and customized for design and development of wave energy converters. The experimental methods involved in designing and developing and testing wave energy converter models on wave basin will also help you to learn experimental studies virtually through this course. This course will therefore incorporate recent research developments including mechanical wave energy converters, multi-body floating wave energy converters and bio-inspired systems which are also used for wave energy harvest called Suzuka dolphins, which are all patented, designed and developed in-house in India. The course is intended to provide therefore good insights into practical design, efficiency estimates and real world applications which can be very useful for learning as well as conducting advanced research in this domain, friends. So, welcome to this course titled Marine Renewable Energy Systems Analysis, Design and Development, hosted by Department of Maritime Engineering at IIT Gandhinagar. Let us quickly look at the overall view of the course content of this course. The course will be taught in different modules, giving freedom to focus on specific topics of interest of your choice. The broad contents what we will cover in this course are as follows. First, we will talk about introduction to marine renewable energy. Then, we will discuss some theoretical background about ocean wave mechanics and wave energy conversion principles, leading to design and development of mechanical wave energy converters. Of course, a wave energy conversion is incomplete without understanding the power takeoff design. So, we will also talk about different and various forms of PTOs applicable to mechanical wave energy converters. Having understood that, we will realize that the efficiency of such systems are limited and they are constrained by certain design parameters. Therefore, to break those barriers, we will start understanding floating and multi-body wave energy converter system designs, and then we will take on to you to hydrodynamic modeling using ANSYS Aqua tool. Therefore, we will also have to understand the experimental studies involved in this kind of scaled models. Then later on we will talk about advanced wave energy converter designs, which is basically bio-inspired systems and other offshore wind farms developed in and around coastal of India conditions. So, the course contents have very diversified interest which will attract students and listeners and participants from various disciplines such as civil, electrical, mechanical, naval architecture, ocean engineering, aerospace, energy, material science, artificial intelligence, machine learning, applied mechanics and so on. Friends, you will have a variety of input people who will be listening to this course, and I am sure that the course contents what we are offering in this course is not a repetition of existing large number of courses in public domain, but this will be specifically focused to help you to learn the concepts of analysis, design and then leading to development of indigenously trained, planned, built and constructed wave energy converters to be specific, and also we will talk about in general renewable energy systems. So, friends, this course has got very classical references listed briefly on the screen at this moment. The SwayamPrabha course of this will also have a list of references which will refer to various publications from refereed journals, international conferences and proceedings of workshops which you have to have an access to learn more about the contents in detail. However, what are all required to learn and understand the course will be discussed on the screen in the classroom model. But if you really wanted to know more about in depth and learn about various parametric designs involved in the specific contents of the lectures, you have to refer to various references listed in SwayamPrabha website. However, the 4 references cited on the screen, which is Wave Energy Device book, it authored by me, Faisal and Abbasi for CRC, will be the fundamental reference for the specific course. Talking about advanced designs on wave energy converters, bio-inspired structures, authored by me and Patil for CRC Press, can also be a good reference material for you to learn more about the concepts of advanced designs which are bio-inspired forms. In addition, ocean wave energy conversion principles, converting mechanical to electrical systems, published by Springer, and modeling and optimization of wave energy converters, published by CRC, will be useful references for you. The later 2 are edited by different authors, the first 2 are authored by us. So, I think these 4 will form a good backbone for you to learn the complete concepts in a comprehensive manner. Of course, the detailed contents of this will proceed as you keep on referring to the reference materials as suggested in the list of references given in SwayamPrabha website of this course. So, friends, be fascinated to learn about the new concept. Most of you may be fascinated to already learn about renewable energy, which is a thrust focus in most institutions being taught in India as well as in abroad. But however, this course is not definitely going to be a repetition of the existing contents, but it will definitely add value to your academic library for a learning exercise as well as for your capacity building on marine renewable energy systems, which is a very important thrust focus. And we are heading towards driving the blue economy in the world, and India will lead in this specific segment in the coming years in the future. So, welcome to this course content, friends. Now, we are going to talk about slightly more in detail about certain basics of this. So, let us first ask a question: what are the processes and concepts involved in wave energy? Let us say wave energy, we talk about the process and concepts. Let us try to learn some more in detail about this, which has been understood by various researchers and presented in various forms. Friends, we all know wave energy is one of the cleanest energy. Still, the technology maturity is not advanced. To harness wave energy is not advanced. On the other hand, if you look at offshore wind energy, you have lot of comprehensive solutions. Which will increase the confidence level in installing wind energy farms. But when you come to offshore application of this, then there is a doubt. When you talk about offshore wind farms, then the capacity building is still limited. Now the question is, why it is so? What is the handicap in not advancing the technology maturity as far as wave energy harvest is concerned? Okay, that is a very interesting. So, we like to put a comment here saying wave energy harvest is inferior, I should say, okay, is inferior compared to the advancements in solar and wind. Okay, I can make a relative comparative statement like this. But the greatest advantage is there is a large source available for wave energy. So, the source availability is very large, but the technology advancement is not mature. Okay? So, we can clearly see there is a gap between these two, right. So, then let us say, how do you define a wave energy converter? Wave energy converter, briefly explained as WEC, is a device, is a mechanical system. Okay? It harnesses waves into electric power. So, what we call this is waves to wire, okay? W to W, waves to wire. So, let us put a brief understanding of what are the various technologies currently available to do this. What are the various technologies available to us? Yes, there are various technologies. We can divide them into three broad outlines. One is, one can use something called point absorbers to harness wave energy. One can also use something called oscillating water columns. People have also used something called overtopping devices to harness wave energy. So, broadly friends, various technologies available as of now in the recent advancements including are categorized in these three headings. So, we can now call these are the popular principles which are cited in the literature for harvesting wave energy. So, there is a classic difference here friends. Point absorber is not a device, it is a principle. Okay? It is a method. It is a method by which I can harness wave energy. Point observer is also a device if you design the device to harness wave energy using this principle. Now, on the other hand, all these three methods or classifications of wave energy technologies harness energy in different degrees of freedom. They do not behave, work mechanically on the same principle. So, the working principles of these three are different. Therefore, these are three different verticals which are classified in the literature under the heading of technologies useful for or principles popular for harvesting wave energy. Okay. Now, what is the basic and severe constraint we have in designing a WEC? So, the basic and which is a serious constraint which we have in designing a WEC in comparison to solar and wind. Let us compare this. The serious constraint is one, the designs of WEC are completely site specific. Therefore, I could say the design of wave energy converter cannot be developed for global site condition and it cannot be developed for a generic design basis. This can be seen as one of the limitation. That is why you see wherever people have designed and developed wave energy converters all over the world, Europe, UK, USA, Australia, etc., they are localized only for the specific site conditions. Because wave energy converter efficiency and harnessed mechanism is related to site conditions, local sea states and water depth at which they are installed. I should say they are commissioned. One cannot have a generic design of this. Okay? Very clearly this was studied and regulated by Sheng and Lewis in 2012. So, it is very interesting that researchers have done an extensive survey and stated that the wave energy converter design cannot be generalized for every scenario of site specific conditions. Now, one can argue, although the energy density is higher than other green energy sources, what are the other general constraints which are not allowing wave energy converters to lead compared to solar and wind? Okay. So, now the other constraints for developing or development of wave energy devices. So, the positive point is energy density of waves is very high compared to any other green energy. No doubt about that. Compared to solar, compared to wind, the energy density available in waves is far higher compared to these sources. But you would see lot of developments happen in solar as well as wind farms, but it is not true for wave energy. Okay? Then what are the reasons for this? The reasons could be the complexity in design. When I say design, it is actually the geometric form. Then the conversion mechanism. Then the directional sensitivity. Then the efficiency. So, complexity in design, it demands huge capital investment. The capex cost is very high for wave energy converters, and of course, there are lot of technical challenges from lab to live. Okay? Whatever lab scale model you do and test and estimate them, when you extrapolate them for full scale device, there are many governing factors which will affect the whole design concepts. Okay. So, this is very clear, and Clements helped us in summarizing this in 2022. Okay friends, so we have realized that though wave energy has got very good energy efficiency, but there are certain constraints which is not allowing this particular sector to take a lead compared to other renewable energy sources. One of the important requirement or the constraint applied to this is site specific design, and other one is complexities in design. So, the complexity in design addressed as geometric forms, conversion mechanisms and directional sensitivity etc. will be addressed in this course content. We will help you how to design a system to have addressed these concepts. So, we will compare about 6 to 7 devices developed, tested and also compared in terms of all its performance indices, so that the viewer can really understand what are the geometric constraints based on which these devices are developed and how they can be different in their geometric form, structural form and of course, how efficiency varies with respect to the constraints and the developments. This will be discussed in this course in detail, friends. Now, let us quickly ask a question for our understanding and learning. Can we compare the wave energy in principle with wind and solar? Okay, that is a good question. Let us see how we can try to address this. So, now let us compare for our enthusiasm ocean waves with the other sources such as wind and solar. Generally, these are the common 3 outputs by which energy harvest happens. So, these are the 3 common outputs through which energy harvest happens. Okay. Now, the main fundamental difficulty with ocean waves is ocean waves generally stay out of phase with wind and solar. In general, if we compare ocean waves with wind, we can blindly say wind is a low frequency phenomena, whereas waves are high frequency phenomena. Now, one can question, sir, waves also have low frequency? I am saying relatively with respect to wind, waves have high frequency. Okay. Now, there is a fundamental difference in designing a system in this context, because generally wave energy converters are designed to harness the maximum. Now, what do you say by harness? We say harness is harnessing is by motion, that is by displacement. The displacements can be lateral and rotational. It can be in the degrees of surge, sway and heave, which are lateral degrees of freedom, which are displacement degrees of freedom. Sometimes it can be in the degrees of pitch, roll and yaw. So, friends, for our learning and understanding, let us describe the degrees of freedom. Let us take a point in space, mark 3 axes. I call this as my x axis, see this as my y axis, and let us call this as my z axis. Okay. Now, the displacements along x, along y and along z are called surge, sway and heave. There is a shortcut to learn this. Let's rub this displacement along y, right. So, one can say sway is with y axis. So, one can really see there is an understanding of this, okay, y with y. So, these are the 3 displacement degrees of freedom. Now, put your, let us say, right hand thumb, place it in the direction of any axis. Let us place it along x. So, the remaining 4 fingers of your right hand will have an indication, right. So, that will give you the direction of this rotation. So, if you keep your right hand thumb towards x, the remaining 4 fingers will indicate in this direction. Okay. So, rotation about x axis we call theta x, similarly rotation about y axis theta y, rotation about z axis theta z. So, now we say theta x, theta y, theta z are rotations about x, y and z. Okay. So, we call this as roll, we call this as pitch and this as yaw. So, friends, these are displacement degrees of freedom. These are rotational degrees of freedom. So, on total, a point in space has got 6 degrees of freedom, right. So, I can design a system in C in open space to move in all these 6 degrees of freedom. And this motion relatively with respect to the waves will help me to harness this energy. So, therefore, harnessing essentially is by displacement. So, if I want to harness the maximum energy, I must make my point or my device to move or displace to the maximum. So, in simple terms in physics, we all know that when a system is displaced or responds to its maximum with respect to the input function, we call this as resonance. So, wave energy devices should be designed, I make this statement again, wave energy devices should be designed to near resonance condition. Therefore, friends, the foremost concept in design of WEC, the foremost concept in design of wave energy converter systems, be it mechanical, be it floating, be it multi-body, be it bio-inspired. In all conditions, the foremost concept should be that the system should be reliable, and structurally safe, because I am designing a system for a near resonance condition. The moment I say near resonance, I am comparing two frequencies. One is the input frequency, other is the output frequency. So, instead of saying input frequency comes from waves, output frequency is the response of the system. So, the response comes in 6 degrees of freedom: 1, 2, 3, 4, 5, 6. So, I must idealize the system to have the predominant response in any 1 degree of freedom. Let us say the predominant response comes in heat, let us say for example. So, I must harness the design in such a manner that the heat frequency should match closely with the wave frequency. Therefore, friends, we always say the geometric design and the safety in the design are important concepts in developing wave energy converters. And since I am always matching my displacement degree of harness with respect to the input frequency, I should say now that wave energy converter designs are completely site specific. So, it cannot be generalized. Okay? That is very interesting. Now, if you want to harness the wave energy and also optimize it to connect it to the power grid supply, then what one should do? Now, the question asked is, I want to, let us say, design a wave energy converter and also connect it to power grid or continuous power supply to the system. Then what should I do? MNRE 2019 states that you can integrate and stabilize the power generation to grids if you integrate wave energy device with solar and wind. So, friends, all the three forms need to be integrated to have a constant, consistent, dynamic supply system to the power grids. So, neither of them can sustain the power grid demand independently. So, now having said this, let us say there are 3 stages of conversion. This is applicable to all the 3. What are the 3 stages of conversion? First is the energy being transferred from C to the mechanical system. The mechanical system can be a mechanical wave energy converter, floating wave energy converter, etc. So, we call this mechanical system to be more detailed as hydrodynamic plus the reaction system. Because hydrodynamics is the input given to the system, reaction is the output generated by the system, which we call as displacement degrees. So, the first stage of conversion is to understand this concept of energy transferred from C to the oscillating system or mechanical system. The second stage is to harness the mechanical system motion to hydraulic or pneumatic power system. using something called power takeoff mechanism. So, that is the second stage of conversion. The third stage of conversion, of course, is electricity generation from the PTO. So, let us try to put a simple block diagram to understand this. Let us say I have waves as coming in to the system. I design the system which is a mechanical wave energy converter, for example. Now, the system will have input from hydrodynamic models, which is from waves. Output is the system's motion, I should say system response. This response must be harnessed to convert the mechanical displacement to oscillatory. So, this is done by using a device or the technique called power takeoff system, in general PTO. Once the PTO is fixed to the energy converter, then this will now give me electricity. Okay. I can now use generators, turbines, batteries to either develop, store or distribute this energy which is obtained from the design. So, there are three stages, friends. So, incidentally in this course we will talk about details of these. We will also talk few basics about this. Okay. So, there are other courses available in SwayamPrabha on renewable energy grid connections, which are also done by one of my colleagues in IIT Gandhinagar, where you can understand the electric conversions of these systems and grid distribution based on the mechanical powers what you get from wave energy converters. So, this course can be a supplement for you to understand the further transfer of mechanical power to electrical grid systems. Okay. So, friends, this is the background we have for the introductory lecture today on this course. So, let us quickly see what is the summary we learned on today's lecture before we wind up lecture 1. So, we understood that what are the basic classifications of energy conversion, what are the basic stages involved in wave energy conversion, why wave energy is not leading compared to wind and solar, what are the constraints we have in optimizing the wave energy converter design, and what are the three different and primary stages involved in wave energy conversion, from mechanical system design to PTO to electrical distribution of the grids. And if you want to really get a powerful output to the power grids, we must integrate all of them together as per MNRE. So, friends, we look forward for you to attend the other lectures as well. We will discuss more in detail about the design concepts of wave energy converter, of varieties of designs where we have done enough experiments, and we have also done technology transfer and patents on these at IIT Madras, and we are now continue to work on this at IIT Gandhinagar as well, using the site deployment along the Gujarat coast. So, welcome to the practical learning of this course, Marine Renewable Energy Systems Analysis, Design and Development, hosted by Department of Maritime Engineering at IIT Gandhinagar. Namaste.